Hello everyone, I'm Luca, and today we're gonna see how we can build full stack applications without caring about the infrastructure headache. So, every time you wanna build an application that has both backend and frontend, you always end up thinking about a lot of tools to integrate in order to make the application work and eventually scale. Not talking about making it secure, because that's another topic that it's always difficult to see when you first implement an application, when you first build an application. So we are gonna see a little bit first where does the headache come from. So we're gonna have a little bit of headache, but I hope it will be small, and then we'll have some solutions that will make the headache go away, hopefully. A few words on who I am. I'm a freelance full stack software developer. That's why I'm here talking about this, because I have this headache almost every day. So I'm trying to not have it in my daily job and in the projects that I create. So I use these technologies, and I'm active in the Internet Computer community, and you will see later what's the Internet Computer. And I'm also active in the governance of the Internet Computer by reviewing the releases that are made to the protocol of the Internet Computer. So let's start with the headache. Imagine you are in a small team, and as I was saying before, you want to build a full stack application that is really simple. It has login, front-end, and then data storage and object storage. So in general, let's say backend storage. So we can try to fill this chart here, and as I said, there are 4 main categories, and of course we also need some computing power in order to store the data and work on the data that we generate and we upload typically from the front end. And a few weeks ago, I did a similar workshop in a company, and we ended up with something like this. So I'm starting to have headache when I look at this representation here, because you can see that in order to build a simple application that has few requirements, we need a lot of tools and technologies, and we need to bring them all together in order to make them work properly. And then we need to secure all these things, and we need eventually to make it scale when it's time. So it's a pain. But let's try to do an exercise together. So imagine again you are in a small team, and we have a specification. We want to build a point of sale app for local businesses. Lugano is really crypto friendly, and I think they are already working on something like this, and I think they would need even more application like this. So that's the perfect case if you want to think about it and also build it, starting from this talk. We have some requirements, and the requirements are to have a login system that preserves the privacy of the users in order not, to track money and users around all the businesses and all the applications that they interact with after or before going to this point of sale and using this point of sale application. Then again, we said Lugano is crypto friendly, so we're going to implement a multi-chain crypto payment system. And we have another requirement, which is probably the hardest one. And it's about enabling users to use our application without having a wallet, without having a crypto wallet. And that's probably the hardest requirement in all these in this list, because in order to build such a thing, we need to think a lot about a lot of tools and platforms that we have to integrate, and I don't think we have the solution if we do it in a traditional way. So let's suffer a little bit together. First thing, we need authentication. What do we choose? We said we want to have privacy, and we also want to make the experience for the users as seamless as possible. So it's already hard to choose what type of authentication system do we want. And then we need to link that authentication system to some kind of wallet somewhere that enable the users to not download anything, but to own tokens and crypto, and to move them around from their balance to the business where they do the groceries, for example, or and then we also need to make sure that we do not track what the users do, or we do not own even the token that the users have. So this is already something really difficult to implement. And then linked to this, we have integrations. So after that, we need, after logging in users, we need a way to make our system talk to some system that manages crypto, right? So we probably are gonna end up talking with the exchanges APIs, or we're gonna talk with the RPC nodes, so the servers that expose an interface for us to talk to the blockchain systems. And so we need to go dive deep into the documentation of each of these systems. We need to understand what they do, and then we need to implement it on our infrastructure. And then we need to make sure that our implementation is working. So maybe we have to create some test data, we have to create some sandbox instances that enable us to test the integrations and stuff like that. So that's starting to become complex. And remember, we are a small team building in hopefully a weekend or so. So it's really difficult. And then after bringing these things together, we need to hire an entire new team to do the infrastructure management. So resources are not enough, and following the traditional path, the traditional way of building such an application is a pain. And you can see where we are going. Like the company that I told you before, we are going to implement such a big system that needs a lot of tools and needs the tools to talk all together. But hopefully, there is a way to stop this suffering. Actually, there are 3 key ingredients to do that. And believe me or not, they are an astronaut, a key, and a bucket. So if you're gonna talk about this to someone, maybe you can start with this sentence: an astronaut, a key, and a bucket walk into a bar. So let's see what's gonna happen when inside this bar. Well, let's go back to the requirements and some better understanding about these elements. And you can see from this representation that the astronaut is gonna take care about the authentication of our users. The key is gonna take care about the integrations that we do with the external systems. So speaking about talking to other blockchains, or to blockchains in general, managing the tokens of the users and stuff like that. And then we need buckets. And the buckets are the canisters. We're going to understand what that word means. And the buckets are going to take care about the infrastructure management for us. So we don't have to care about it. let's start with the first key element, the astronaut. We're going to use the internet identity. The internet identity is a system that enables us to give our users the possibility to authenticate themselves on our application without using passwords. This morning there was a really interesting talk about passkeys, and that's all about that. So the internet identity uses passkeys to enable users to log in into their applications, the applications they want to interact with, without anything else that their biometrics or a PIN or a security key that you insert into your computer, or in general, into your device. And the internet identity is also made in order for people and developers not being able to track users from one application to the other. So if I use the internet identity and I integrate the internet identity into my application, I have no way to know what other applications that user is using. And that's a key point, because otherwise we would have used a system that gives us an identity provider or such a service, but that identity provider tracks all the usages, all the applications that the user use. So that can become a problem. And imagine if this were the way that users authenticate to any applications, not only our applications, but any applications on the web. It's really like, if someone logs into my point of sale application, then I can know what post they created on Facebook and what other transactions they made to other exchanges and whatever else, you name it. And then, of course, since we are using passkeys, it's also possible for our users to associate more than one device to their identity in order to log into applications from different devices. And again, since we use passkeys, if their device have a biometric authentication system, or if they have a security key, they can use any device and link it to the same identity. So they can access the same application across multiple devices. So the astronaut, why the astronaut? That's just because it's the logo of the internet identity. So this is our first key ingredient. But we are developers, and so we want to see the code. Actually, this code is not complete, of course. It's not all the code that we need to run our application, but that's just an extract of what we need to integrate the internet identity into our system. And as you can see, we said we are going to build a full stack application, so we're going to build a front end and a back end. And on the front end, this is what the code would look like. So we have a library, and then we specify an identity provider, which is the internet identity, that weird URL down there. And then we can interact with our backend using the identity that the users create. Then we need to build an entire infrastructure on our backend in order to recognize the users, know what the identity they're using, and how they logged in, and so on, right? Well, no, in the sense that the platform that we're going to use is going to handle that for us. So you see on the front end, I'm going to call the update user method. And on the back end, and that's Rust code, if some of you have recognized it, because we use a lot of Rust to build such applications. So in our backend, we have an endpoint that has the same name, of course. And inside the endpoint, we can access the ID of the users of the user that is calling the endpoint just by using that function, the caller function. So you see, we don't have to care about verifying the authentication, verifying the whatever JWT, cookies, session, whatever we are used to, but we just need to call that function inside our code and have the ID of the user. And of course, the ID of the user is the same across multiple devices, thanks to the internet identity, and the ID of the user, that code doesn't get executed if the authentication is not made properly by the user. So when we execute our code, all the authentication layer has already been taken care of. And then we need to manage payments, and that's where the key element in our ingredients come into play. So we are gonna manage the payments with using threshold signatures. Threshold signatures is a pretty old way of creating signatures on top of any message that we can think about. And specifically for this application, we are gonna use 34 servers to do the signatures on the messages that we want, that we wanna sign. And why we wanna sign messages? Because we wanna interact from our application to with other blockchains. So we wanna make it possible for our backend to sign some transactions and broadcast the transactions to other blockchains. But in order to do that, we would have had to either integrate a system that manages the keys and manages everything, all the security for us, or otherwise, we can use this system to use threshold signatures among 34 nodes, so also for security purposes, in order to manage the signatures of the transactions. As we said, it's gonna be multi-chain, so this system enables us to sign almost any type of transaction for any blockchain. And also, we need to make sure that the users have access to those funds, right? Because we are gonna sign transactions for them, but we need a way to enable them to trigger the signature on our backend. I know it's a bit hard to understand, but we're gonna see it in the code. So basically, we are gonna derive a key in a threshold signature scheme different for each user. And how are we gonna do that? So this is, again, some backend code, again, written in Rust. And you can see there is a method, which is the sign method. Of course, our application is not gonna expose a sign method. Maybe the application is gonna expose a method called send money to business, or send money to other users, or something like that. But the idea is that inside our method, we again call the caller function in order to know who is the user calling this method. And then we are gonna derive a key for that user. So each user will have a different key. And having a different key means that each user will have a wallet in our backend. But we are gonna, it's a bit, it doesn't sound really good, because we are centralizing everything inside a single backend, and we are gonna derive keys for the users, but we are gonna manage them. So what's the point? The point is that we can prove to our users that our backend is executing exactly this code. And we're gonna see it in the next key ingredient, which is the canisters. And so users can be sure that our backend is signing the transactions for them and only for them. And they are the only ones that can sign transactions that can trigger this method and obtain a key in order to sign a transaction. So, and then we're gonna call the, yeah, there was also some highlighting here. So that's also why I called it non-custodial wallet, because we are gonna do everything on the backend, but we're not the custody of the keys, because we're gonna do it with this network of 34 servers all together that do the signature for our users. And then we're gonna call this method in order to sign the request based on whatever logic we're gonna implement. And again, on the front end, that's super simple. I could also remove that part of the code, because once we have authenticated the users, we can just call this method of our backend in order to make the users sign a transaction and make the user make a transaction on a blockchain of their choice. Last key ingredient is canisters. Well, canisters is a really weird word, and we can think about canisters as buckets. That's why I was talking about buckets before, and that's a cool representation of such a bucket. And we have to think about canisters as our main piece of infrastructure on our backend that enables us to do all the things that we have to do in our business logic. So the canister is actually the building block for our application. Everything we're gonna do on our backend, we're gonna do with one or more canisters. What are the features of a canister? So a canister, I like to call canisters as stateful, serverless, whatever, name it. So container, backend, whatever. The most important words are stateful, serverless. And that means that, as you saw before, there were some methods that we have created in our backend code. And these methods are invoked in a serverless way. So they are like lambdas for our traditional, a traditional application. But these lambdas have access to the data. So these lambdas have the data directly inside the memory of the lambda itself. So that's why I call them stateful serverless, because they don't run if you don't invoke them. But when you invoke them, you already have the data there. So you have no need to connect to any database, no need to connect to any S3 storage, no need to connect to any authentication system, as we said, as we saw before, just because inside the canisters, we already have the entire state of our application, and we can run them in a serverless way. But it's even cooler, because the canisters are interoperable. So other people are gonna build other canisters, like, for example, exchanges or wallets for their users. And the cool thing is that from our canister, we can interact with their canisters. And we can do it without caring about all the infrastructure and all the security that is needed typically to communicate with external systems. And that's because the environment where the canisters run, it's a standardized environment, and each canister exposes some methods. And once I know the methods that the canister exposes, I can directly interact with the canister. I didn't include it in the code before, but if we want to interact with another canister, it's really similar to writing the signature function that we saw, like the sign with the CDSA function. It's just one line. We just need to know what's the address of the canister that we want to interact with, and we can call the endpoints of the canister. And guess what? The other canister will see a message coming, and with the caller function that we saw before, they will be able to authenticate our canister in order to handle the request. So there is no difference anymore between canisters and users. All the actors inside this system can talk to each other. And verifying their authenticity is as simple as calling a function inside our code. There are many other really cool features about canisters, but we are going to see now one of the cool features, one of the coolest features, which is certified data. And certified data means that, as I said before, we have the state inside our canister, and we can actually prove to our users that the state that they created doesn't get tampered with. And so we can put all the data of the users inside these buckets, and the users are able to verify that that data doesn't get changed. We can also, in addition, put the contents of our frontend inside the canisters. So we can certify to the users that the frontend that they are accessing is exactly the frontend that they find in the source code. And this is thanks to the certified data and the fact that canisters have the state inside, directly inside, together with the code. Okay, but we still need to manage infrastructure, right? No, we don't. And that's because what I said before, because canisters already manage everything for us. So we don't need to connect to any database. We don't need to put a load balancer in front of our canister. And we don't need to integrate with external or internal systems that manage atomically the aspects of our application, like, again, the authentication or the S3 storage and stuff like that. And this is thanks to the internet computer. So finally, we are gonna put this all together, and everything that I said till now is built and can be built on the internet computer. And you can see here a super simple representation in which we as developers upload our code to the internet computer. The internet computer, now people are starting to call it the world computer because more and more people are building applications on top of it. And but we can call it the internet computer. The internet computer is made of sub-networks that are called subnets, and you can see the representation there as network 0, 1, blah, blah, blah. And do you remember the 34 nodes that I told you before? That's one of the subnets of the internet computer that takes care of signing in a threshold manner the messages that we want. So if we deploy our application on one of those subnets, we can interact with that subnet and ask for signatures. And as I said before, we can also put our website in the state of the canister, so we can provide our users with experiences that are directly available to them. This is an overview of last night from the dashboard of the internet computer. There are right now 35 subnets and around 1,400 nodes that make up this subnet. And you can see here the geographical distribution. Yeah, that's not so, you cannot see so much, but this is the map of the world. So you can imagine that the nodes are all over the world, basically. And so this is the infrastructure on top of which we can build our canisters and we can build our applications. But let's do it. So let's try out what interacting with such applications mean. If you scan this QR code, you end up on the Internet Identity homepage, and you can create your Internet Identity in order to start interacting with the applications built on the Internet computer. While I talk, you can go ahead and create the Internet Identity. It should take literally 2 or 3 clicks, no more. And you will see that you will be able to be authenticated in your in the system with your biometrics. And if you followed the speech before, you know that your biometrics are not saved anywhere except from your device, but I'm gonna tell you again. So your biometrics are not gonna be saved in these across all these nodes that we saw before, but they are just a way for your device to authenticate you and authenticate you to the Internet Identity Service. So have you created it? You probably have ended up with a number, right? Which is called anchor. That's just the number that identifies you on the Internet Identity, and that you can use to access from other devices, so to connect other devices to the same identity. Now you can access one application, which is Oisy. Oisy is actually a browser wallet, so it's kind of similar of what we wanted to build before, point of sale application, because Oisy enables us to access with our Internet Identity and enables us to hold cryptos without managing the private keys. So now that you end up on Oisy, you can click on create account or whatever button there is there. And in a few seconds, you will be logged into Oisy, thanks to the Internet Identity and and the identity that you have just created. Who is inside Oisy? There, 1, 2, great. Yeah, I'll give you a few more seconds. Another one, another one, another one, great. But yeah, let's stop talking about crypto. Let's see actual applications built on the internet computer. So let's join a group where we can chat. So again, if you scan this QR code, you end up on OpenChat, which is another application built on the internet computer. And guess what? You will be able to access it with your internet identity. And as soon as you will log into OpenChat, you will be redirected to the group. And I'm here watching who's joining. Who's inside? I still don't see anyone in the group. You have to create a little. You just have to set your username and you're done. Oh, buongiorno. Great. Yeah, from down there. Cool. Yeah, other people are joining. Great, great. And actually, since it's all built on the internet computer, OpenChat gives you the possibility to hold tokens. So you could even send tokens to your contacts via OpenChat, and then you can send your tokens to OISI and put them there in your wallet. So this is done thanks to the fact that the canisters that make up these applications are all interoperable, and they can all interact between each other in order to give you such a seamless experience and such a integrated experience in the entire ecosystem. Great, I see messages coming up here, cool. Yeah, we have some time for questions.
You just mentioned that I can send some tokens in the chat. Oh, sorry, I should have noted. You just said that you can send someone else tokens in the chat, and then they can send into OISI. It means that since you have one identity but kind of two IDs somehow, they are two separate balances, right?
Yes.
And there is no easy way to tell that what is my OISI balance compared to what is the balance in the chat.
Exactly, yeah. The work is in progress to enable. I don't think if that's applicable to the balances, but in general, to make users able to bring some data between applications, the internet identity will support or is already supporting verifiable credentials. So the internet, you can go, you can do it if you want in your spare time or like after this talk. You can go on the side AI and receive a credential that tells other systems that you are a unique human. And then you can go into OpenChat and show that credential, and now OpenChat knows that you are a unique human. And this is all thanks to the fact that the internet identity enables you to bring around the credentials that you want, but you choose what credentials to disclose to other to the services that you use. So I'm not sure if this is right applicable to balances because they change a lot, but for other types of data, you can bring them around. Yeah.
Thank you so much.
And while other questions come up, I wanted to show you another use case. Actually, these slides are hosted on the internet computer. So you can scan the QR code and end up here. And as you can see there, there is the address of the canister that I deployed a few days ago. And as you can see, I'm accessing the canister directly from the browser. So there is no extension or anything needed. I can just access the content of the canister, so the assets inside the canister, from my browser. And actually, if you are gonna build this, are gonna reproduce the build from the source code, you can verify that the slides hosted here are the same as in the source code, if you want. Yeah, so this is another use case. I just found it nice to do. And if you go on this source code page, you can see that it has been created from a template. So before creating these slides, I created a template. And you can use this template to host your slides on the internet computer if you want. And there are all the instructions in the README. Since we have a few more minutes, I'm gonna do a live demo with you. So I'm gonna create a project entirely from scratch in this. I think we have 6 minutes, and we're gonna deploy it on the internet computer live. Let's try. So I'm gonna use the DFX command line tool, which you can download from the internet computer docs. And I'm gonna create new Vox Days 2025, whatever. Rust. I have no any doubt. I'm not gonna integrate the internet identity for now because I'm not gonna let the users log in. So you see some code has been created both for the front end and the back end. And yeah, node is taking a little bit. And in the meantime, I will open Windsurf, yeah. Open folder. I just wanted to show you the structure of a project on the internet computer. So that's gonna be inside talks. This one. And so basically the structure is this. We have the main file here, which is this dfx.json, which if you think about your previous experience is like the Docker file or the Docker compose file. And you see there are some canisters and there are instructions on how to build those canisters. And then there are the folders where the canister source code is. So there is a backend canister that simply exposes a method called greet, which receives a name and says hello name. And a frontend that is in JavaScript, HTML, and CSS like every other frontend. And the frontend will enable users to have an input and say and put their name and call the canister. So let's not waste time and deploy it on mainnet. So in order to deploy on mainnet, I'm gonna run this command without this and specifying these parameters. So you see now the CLI is creating canisters inside that infrastructure that you saw before. And it's gonna be deployed only on one subnet. So actually the CLI chooses randomly which subnet, but you can also choose on which subnet you want to deploy your canisters. And then we are compiling the code. Yeah, some Rust compiling compilation stuff. So we are installing the code. So you can see, oh yeah, it's too fast. So I will show you later. Yeah, we have our application online. So if we click on this, you see that the format of the URL is a little bit like what we saw before for the slides. And if we take this URL here and we go, here we have our front end and hello voxed, and we get a reply from the backend. And let's go look into the details. So if we go on the dashboard of the internet computer and we search for our canister ID, we see that there is a canister exposing a method, the greet method, as we were expecting. And if we click on this, we can see that in these 2 seconds, we have deployed our canisters in all these servers across the world. And the state is replicated across them and is always the same across all these servers. I guess it's over. Yeah, and by the way, it's among other 500 canisters that people have deployed in that subnet.
I have a question. You said the canister are. You said the canister are stateful containers, whatever. This means they contain data in memory. But, for example, OpenShard is a canister. It contains the message you just sent. But if the canister dies, restarts, where the message go? Is there locked?
There are some parameters that you can configure in order for your canister to stay alive for a specific amount of time, which can also be years, in order for you not to lose the data in that time. So the canister gets freezed, and so the data stays there. And after that time, the data are gone. Yeah, but you can configure
But
the
if it's
parameters.
crash, you lose the data.
No. And actually, there is I couldn't say it in the talk because there wasn't time, but the one of the coolest things of canisters, believe me or not, is traps. So canisters, when there is a crash, they trap and they revert all the state changes that they did in that invocation, so you don't alter the state in a way that you don't want. And yeah, yeah, boom.